Welcome to this series on process intensification and flow chemistry. I am Professor Anil Kumar from IIT Bombay, and this is part 10 of this series. In this session, we will look into the examples of industrial continuous flow processes. We will discuss examples from Indian industries also. Many of the slides in this lecture are taken from various peers, and due credit is given on respective slides. This one is the famous example from DSM. They could successfully develop and scale up the process for the aliphatic O-mononitration of a diol. It is important to note here that the dinitration has to be avoided due to the explosive nature of the dinitrated product. This process was not safe to scale up via batch, and hence, continuous flow provided the required solution. Silicon carbide reactors from Chemtrix were used for the scale-up process. Silicon carbide reactors are also suited for the highly exothermic reactions, such as butyl lithium. This is an example from one of the leading Indian industry, wherein they used multiple silicon carbide reactors to telescope the whole process. This is an example of Dakin oxidation. It is important to note that the process was optimized using a very small silicon carbide lab module, Pertrix, from Chemtrix. Interestingly, the lab version of the liquid-liquid extractor was employed for the downstream process. Silicon carbide reactors can also be used for very large production. As shown here in this example, per acid acylation was carried out at a scale of 10,000 tons per year. We can also use the spinning disk reactors for the highly exothermic butyl lithium reactions. One can start with the synthetron reactor for the lab scale optimization, as shown here. This can then be scaled up using the larger disk synthetron. As discussed earlier, one can operate at very high flow rates, even for highly exothermic reactions, as the surface area to volume ratio is very high in these reactors. A 5-inch disk reactor enables a production of 140 tons per year. It is not surprising that the larger spinning disk reactors, like SpinPro from Fluid, can be operated at the rate of 100 kg per hour dosing of butyl lithium, and that too at or near room temperature. One can imagine the savings as compared to carrying out this reaction at -78 degrees and with dropwise addition using batch tools. One can also use the spinning disk reactors for nitration. Here is an example from a large Indian company, wherein a highly exothermic nitration was optimized on the synthetron, followed by scale up using SpinPro. Apart from high heat exchangeability, spinning disk reactors also provide intense mixing. Therefore, these reactors are ideally suited for heterogeneous reactions. Here is an example of the gas-liquid reaction using spinning disk reactor. Here is an interesting example of scale-up via continuous flow without intensification over the batch process. This is the Ritter reaction using acrylonitrile. We all know how smelly the acrylates can be. Therefore, it is a nightmare to operate a large-scale production using acrylates via batch technology. Whatever precautions one take, one cannot avoid smell in a batch production due to various seals commonly used in batch tools. In case of flow reactors, there is no such issue, as one can completely eliminate the leaks. In this case, there was marginal improvement in yield and throughput over the batch. However, there was significant improvement in terms of process controls and smell. As discussed earlier, agitated flow reactors provide an excellent opportunity to scale up multiphasic reactions. This is an example of biphasic reaction using epichlorohydrin. Even the heterogeneous reactions, such as biocatalysis, are best suited for agitated reactors. This was demonstrated for the esterification reaction, wherein significant improvements over the batch process were observed. As it is evident that many Indian and foreign chemical companies have adopted continuous flow technology. However, they are still reluctant to make public declaration of the same. Cipla is one of the large chemical company and the first Indian company to publicly declare the implementation of continuous flow tools for their production setups. This example is the production of an agrochemical via continuous flow and is from a large Chinese company, Shaoxing Eastlake Biochemicals. The flow reactor used for this production is the Miprowar reactor from Airfeld. The requirement was the production of 10,000 tons per year. In the traditional batch production, 20 reactors of 25,000 liters were used to do this. One can imagine the size of the plant, it was like a mini city. This was replaced by a single Miprowar reactor, which was just 7 meters long and just over a feet in diameter. One can appreciate that the footprint of this reactor is so small that one can easily install this in any small chemical plant. This small footprint reactor could produce the required amount of the product. In fact, this is an example of one of the fastest transition from lab to the production scale, wherein it took only few months to complete all optimizations, installations, and trials to start the production. This is one of the major attraction of continuous flow technology, as it can easily be scaled up without much intervention of design complications. It is important to note that flow reactors can also handle highly viscous and sticky products, as commonly found in polymer production setups. This is an example wherein the production of a superglue using the spinning disk reactor was carried out successfully. Finally, here is an example of the successful scale-up of an emulsion polymerization, wherein the mixing is very critical for controlling the particle size. When the same was explored via continuous flow method, one obtained much narrower particle size distribution. This is one of the reasons that continuous flow reactors also become the first choice for the scale-up of crystallization processes. In this video, we have discussed so many of diverse chemical production processes, which were intensified via continuous flow technology. I am sure you all will agree with me that this is an ideal platform for process intensification. Slowly and steadily, large number of chemical processes are shifting from traditional batch to continuous flow processes. In fact, continuous flow technology is projected as the process for the chemical factories of tomorrow.